guys, my name is Landon Oubre. I am Group 3 lead, and I will be presenting to y'all the jet engine experiment. So the objectives for this experiment are to gain a better understanding of the turbogen gas turbine system as a whole, and to understand all the details about the sensors and controls that make up the system. So the jet engine is closely related to the Brayton cycle, and how the Brayton cycle works is it compresses fuel and air and then sends it to the combustion chamber where it's going to be burned, and then the exhaust gases from the combustion chamber are then sent to the turbine and expelled into the atmosphere. So for our control panel, at 1 we have the master switch, 2 is our start button, which is the green one, 3 is our stop button, which is the red one. If you look all the way to the right, we have 4 and 5, which are our power lever and our load lever. Number 6 is our LCD display, and number 7 is going to be our inlet temperature display. Next to the inlet temperature display, we have 8 and 9. For 8 is the engine rotational speed. For 9 is the turbine rotational speed. And then below those two displays are going to be 10, 11, 12, and 13. For 10, we have oil pressure, 11 our engine pressure, 12 is our fuel pressure, 13 is our air pressure, and then if you look to the right again, for 14 and 15, we have our voltage indicator and warning light. So for this procedure, there's going to be 3 different steps. We have the pre-start, the start, operation, and shutdown, and data collection. For our pre-start, we're going to examine the area around our turbogen and make sure that we have all the proper gear on. For this experiment, we're going to have hearing protection on. We're going to make sure that we know the location of the fire extinguisher in case anything goes wrong in the lab. We have to make sure that our master switch is turned off and our coaster wheels are locked in so that the turbogen doesn't move around while the jet engine is operating. We want to make sure that our engine throttle lever is at its lowest position and that our load lever is in the pins position. We want to conduct a visual inspection to make sure everything's intact, nothing's broken. We want to make sure that we have the proper fuel and oil quantity. We also want to connect our electrical and air service to the turbogen and make sure that our air pressure indicates a minimum of 120 psi. And then we want to hook up our DAC system via USB. So for the start, operation, and shutdown, we want to turn the master switch on and verify that our inlet temperature, engine RPM gauge, and turbine RPM gauge are all on and functional. We want to move the throttle lever up in the up position to make sure that the LCD display is working properly, and then move it back down. We want to move our load lever into the pin position, and then we want to press our green start button and collect all of our data. And then once the data has been collected, we want to press the red button to stop the engine and verify that the engine's off. We're going to put our throttle lever into the middle position to make sure that the LCD display flags, the little flag that shows. We're going to push our red stop button again to arm our air clean function, and then we press the green button to activate the air clean function. For the data collection part, we're going to click log data before we start the experiment. We're going to edit the file name and save it to our desktop, and then once it's finished, we're going to click log data again so that we can save all those results. So for our sample calculations, we're going to be calculating for compressor inlet pressure and air density first. To find the pressure, we have to do the force over the area, and then to find the density, we're going to do the mass over the volume. We also need to find the velocity for the compressor, which is going to be the displacement over the time it takes to reach the final displacement. We're also going to find volume flow rate, which is equal to the velocity times the cross-sectional area. Our mass flow rate into the compressor, which is our density times our velocity and the cross-sectional area. And then our Mach number, which is the velocity over the speed of sound. To find the speed of sound, we have to use that equation right next to the Mach number equation. And the only variable that we need to plug in is the ambient temperature, which will be 25 degrees Celsius because we're going to have the turbogen outside. And then we plug it in and solve for our Mach number. And any questions? Yeah.